Hello everyone, welcome to Gradeup. My name is Shantanu Sanwal. We are continuing the course on strength of materials. Okay. In the last class, we have seen about the concepts of bending and torsion, and in this class, we will be solving the previous year papers of recently concluded GATE exams on the topics of bending and torsion. So let us begin with the questions. The 2015 set 1. Consider a stepped shaft subjected to a twisting moment applied at B as shown in the figure. Assume the shear modulus G as 77 gigapascal. The angle of twist at C in degrees is. Okay. So in this case, the torsion or the torque is applied at the point B, and in this BC section there is no torque applied. So the torque for the section BC will be equal to 0. Therefore, the theta C will be equal to theta B, okay, because no torque has been applied at this section in the BC, okay. So theta B will be equal to TAB LAB upon GAB JAB, okay. So the torque that has been applied in the section AB is equal to 10 Newton meter, okay, but we will convert all these values in mm. So 10 Newton mm into the length is 500, because this length is also given in 500, okay. These dimensions are in mm, it is specified, so we will take all these values in mm. Divided by G is 77, okay. So 77 into 10 to the power 3 megapascal into J is nothing but pi by 32 d to the power 4, and the diameter for this section is 20, so into 20 to the power 4. Okay, and this you will get the value as 4.1338 into 10 to the power minus 3, but this value will be in radians. Okay, so for converting this value into degrees, you need to multiply this value by 180 by pi. Okay, so you will get the answer as 0.2368 degrees. This will be equal to theta B and also equal to theta C. Okay, so this is the answer. The angle of twist at C is 0.2368 degrees. Okay, the next question.
Subscribe to our channel and press the bell icon to never miss any update. From Gradeup.
2015 set 2. A hollow shaft of 1 meter length is designed to transmit a power of 30 kilowatt at 700 rpm. The maximum permissible angle of twist in the shaft is 1 degree. The inner diameter of the shaft is 0.7 times of the outer diameter. The modulus of rigidity is 80 gigapascal. So it is asking the outside diameter in mm of the shaft. Okay, so let us see what are the values that have been given. Power is given as 30 kilowatt, and that is the rpm has been given as 700 rpm. Okay, so we know first of all that P is equal to 2 pi nt by 60. So supplying the value of P as 30 into 10 to the power 3 and the value of N as 700, we get the value of T, that is the torsion or the torque, as 409.25 Newton meters. Okay, then it is given the theta is given as 1 degree, or which can also be written as 1 into pi by 180 radians. Okay, so theta is equal to TL by GJ. So from here, pi by 180 equal to T is 409.25 into 10 to the power 3, because again converting it into mm. L is 1, so again converting into mm, that will be 1000, divided by G is 80 into 10 to the power 3 in megapascal into G into J is pi by 32, and the outer diameter by inner diameter, but outer diameter to the power 4 into 1 minus k to the power 4, and in this case this k is nothing but 0.7, the ratio of inner diameter to outer diameter. So on supplying these values, we will get the value of outer diameter as 44.5 mm. Okay, very simple. Just you need to calculate the things and keeping the units as uniform all throughout on both the sides, and you will get the answer as 44.5212 mm. Okay, let us continue. Next question, 2015 set 2 again. The hollow shaft, the outer diameter is twice of the inner diameter. Okay, needs to transmit 20 kilowatt at 3000 rpm. Maximum permissible stress is 30 megapascal, then the outer diameter is. Okay, in that case it was given the torsion, the angle of twist was given as 1 degree. In this case the permissible shear stress is asked. Okay, again the power is again 20 kilowatt and the rpm is 3000 rpm. Okay, so again using that same formula, P is equal to 2 pi nt by 60 and keeping this value in watts, that is 220 into 10 to the power 3, we get the value of torsion or the torque as, what will be the value? We will get this value as 63.66 Newton meters. Okay, and we know that tau max is equal to 16t upon pi d naught cube 1 minus k to the power 4. Okay, this t is known to you, but this will be 63.66 into 10 to the power 3 Newton mm. Okay, d naught you need to find out, and k is equal to di by d naught, that is equal to 1 by 2, or which is equal to 0.5. So just applying this value, we will get the value of tau max as, okay, the tau max has been given, the tau max has been given as 30 megapascal. So on supplying this, we will get the value of d naught as 22.58 mm, this value, that is option B. Okay, very simple questions, just you need to have the uniformity of the units that I am again and again emphasizing upon. Please keep a note of it that the unit should be uniform on both the sides. Okay, either the length and all the values has to be converted into the meter or in mm, but since these values are given in megapascal or gigapascal, it is better to convert these values into mm. Okay, and then continue with the question. It will be really easy for you. Next question, GATE 2016 set 1. The cross sections of two hollow bars made of the same material, okay, please note these words, same materials, are concentric circles as shown in the figure. Okay, it is given that R3 is greater than R1 and R4 is greater than R2. The outer diameter of this one is greater than this and the inner diameter of this is greater than this. Okay, and the areas of cross sections are same. Areas of cross sections are same. Okay, J1 and J2 are the torsional rigidities of the bars on the left and the right respectively. Then the ratio of J2 by J1 is asked. Okay, first of all it is given that R3 is greater than R1 and R4 is greater than R2, and it is given the areas of cross section is same. So the area of cross section for this will be pi R2 square minus R1 square, and this is equal to pi R4 square minus R3 square. Okay, so just keeping this, take this as equation 1. Then second thing, same material is used, so G1 will be equal to G2. And next thing, it is asking about the ratios of J2 by J1. So J2 by J1 is simply pi by 2 R4 to the power 4 minus R3 to the power 4 divided by pi by 2 R2 to the power 4 minus R1 to the power 4. This pi by 2 gets cancelled from the numerator and denominator, and then what we have, see this is again very simple, just you need to use R to the power 4 square minus R to the power 3 square into R to the power 4 square plus R to the power 3 square upon R to the power 2 square minus R to the power 1 square and R to the power 2 square plus R to the power 1 square. Okay, now since R to the power 4, R4 to the power square minus R3 square is equal to R2 square minus R1 square, so these two terms will get cancelled and we are left with this thing. Now you know that R4 is greater than R2 and R3 is greater than R1, so the term in the numerator will be greater than the term in the denominator. So this ratio of J2 by J1 will be greater than 1. Okay, so the option will be, correct option is option A, that is the ratio of J2 by J1 will be greater than 1. Okay, let us see the next question asked in 2016 set 3. The cross sections of two solid bars made of the same material are shown in the figure. Same material. Okay, the square cross section has the flexural or bending rigidity as I1, while the circular cross section has the flexural rigidity of I2. Both sections have the same cross sectional area. The ratio of I1 by I2 is. Okay, let us take this side of the square as A and the diameter of this circle as D. Okay, so since it is given that the same cross sectional area, so we will use this condition, that is A square is equal to pi by 4 D square, the first equation. Okay, and then we know that I1 for the square is equal to A to the power 4 by 12 and I2 is equal to pi by 64 D to the power 4, and we need to find I1 by I2. So we will put these values, that is A to the power 4 by 12 upon pi by 64 D to the power 4. So from here we can find out that D square is equal to 4A square by pi. So on substituting this value, we will get I1 by I2 is equal to A to the power 4 by 12 upon pi by 64, and D to the power 4 will be the square of this. This is 16 A to the power 4 upon pi square. So A to the power 4, A to the power 4 gets cancelled. This pi 1 value gets cancelled, and we are left with 1 by 12 into 64 by 1 and 16 by pi. So this and this goes 4 times, this goes 3 times. So we are left with pi by 3. So I1 by I2 is pi by 3. The correct option is option C. Okay, I1 by I2 equal to pi by 3. So next question, 2016 set 3 again. Two circular shafts made of same material, again the same material, one solid and the one hollow, have the same length and polar moment of inertia. Okay, same length and the same polar moment of inertia, that is L of solid is equal to L of hollow and J of solid is equal to J of hollow. And both are subjected to the same torque, that is torque on the solid and torque on the hollow are also same. Theta S is the twist and tau S is the maximum shear stress in the hollow solid shaft, whereas H and this theta H and tau H are the twist and the maximum shear stress in the hollow shaft. Then which one of the following is true? Okay, so you know that theta is given by TL by GJ. Since T is same for both the cases, L is also same, J is also same, and they are made up of same material, that means G is also same. So theta will be same for both the cases, for the hollow and for the solid. So your this option and this option automatically goes out. Our correct option can be either this or this. We will see this from the maximum shear stress case. Okay, now let us see. First of all, the given condition is that the J, that the polar moment of inertia is same. The polar moment of inertia is given by pi. If we take the radius, this is the whole solid, R solid to the power 4, and this will be pi R hollow power 4 minus R hollow to the power 4. Okay, this pi and pi goes off. RS4 equal to, if you take this value outside, that is RH to the power 4, 1 minus K to the power 4. And you can see this K is the ratio of a small, that is the internal radius of the hollow upon the external radius of hollow. So this value will always be less than 1. This value is less than 1. That means this value is also less than 1, because this is subtracted, something is subtracted from 1. So this value will be less than 1. But the multiplication of these two values is equal to this value. That means that RH will be greater than RS. Okay. For the hollow, the external radius will be greater than the external radius, or the simply the one radius that is for the solid shaft. Okay. Then you know that tau max is equal to TR by J by the torsion equation. What is the torsion equation? Tau max by R equal to T by J equal to G theta by L. So taking these two terms, we get tau max is equal to TR by J, and as the T and J are same, but the R is higher for the hollow shaft, so the tau for hollow will be greater than tau for the solid. Okay, so we are getting this option as correct. So option D is the correct option for this question. Okay, now let us see the next question. 2017 set 1. A motor driving a solid circular steel shaft transmits 40 kilowatt at the power of 500 rpm. If the diameter of the shaft is 40 mm, the maximum shear stress in the shaft is, okay, the power is 40 kilowatt, rpm is 500 rpm. Okay, so again using P is equal to 2 pi nt by 60. Okay, how this is coming? Yeah, do you know that the T is equal to tau into omega, T into omega, P, that is power, and T into omega, and omega is equal to 2 pi n by 60. So from here we are getting this expression. Okay, so using this value of 40 into 10 to the power 3 and substituting this value, we will get the value of T as 763.94 Newton meters. Okay, and tau max is nothing but 16 T by pi d cube. So tau max you need to find out. D has been given to you as 40 mm. Just using this value as 763.94 into 10 to the power 4, converting into Newton mm. So we will get the value of tau max from here as 60.7 megapascal. 60.7 megapascal. Okay. Next question, 2017 set 1 again. Consider a beam with a circular cross section of diameter d. The ratio of second moment of area about the neutral axis to the section modulus of the area is. Okay, it is asking you about the area, that is the I by Z. You know that Z is equal to I by Y max. Okay, and it is asking you the ratio of I by Z, that is equal to Y max, and Y max is nothing but for the circular cross section of the diameter d is nothing but the d by 2. So the correct option is option A, d by 2. Very simple question. Okay, the next question, GATE 2018 set 2. A hollow circular shaft of inner radius 10 mm, outer radius 20 mm, length 1 meter is to be used as a torsional spring. Okay, if the shear modulus of the material is 150 gigapascal, the torsional stiffness of the shaft in kilonewton meter per radian is. Okay, it is asking you the torsional stiffness. What is the torsional stiffness? What do you mean by torsional stiffness? It is very simple. For the torsional stiffness, you know the torsional stiffness is given by Q, that is equal to T by theta, that is the torque required per unit angle of twist, and this is equal to TL by GJ. So on substituting this, you will get the torsional stiffness as GJ by L. Okay, just simply substitute the values. G is equal to 150 into 10 to the power 3 megapascal or Newton per mm square. J pi by, this is given as the radius, so pi by 2, 20 to the power 4 minus 10 to the power 4. Okay, this is for the radius. Then this will be or you can get just convert this value, or you can just, but the value has been asked in kilonewton meter per radian, so you can just use this also, or you can convert these values into Newton per meter also, Newton per meter square, or simply Pascal also, but I will use it in this form only. Okay, no problem, you can just use it this, but you have to see the values have to be converted into this, so it is better that you write this in meters only. Okay, this meters. And for the J also, you just take pi by 32 into 20 mm, this will be 0.02 to the power 4 minus, or if you can use it the value of diameter, because this is the radius, so just use the values of diameter minus 0.04, because this 32 is valid for diameter, minus 0.02 to the power 4. The radius is 10 and 20, so just converting this into the diameter of 20 and 40, so this is 0.04 and 0.02. Okay, and the length is 1 meter. Okay, so just simply substituting the values these from here, you will get the value of Q, or the torsional stiffness, as 35342.9 Newton meter per radian. But this is not asked in Newton meter, this is asked in kilonewton meter, so just divided this value by 1000, we will get 35.343 kilonewton meter per radian. So the correct answer for this is 35.343 kilonewton meter per radians. Okay. The last question, 2018 set 2. A bar of circular cross section is clamped at the ends P and Q as shown in the figure. Okay, this is shown here, the clamps. Okay, and the torsional moment of T equal to 150 Newton meter is applied at a distance of 100 mm from the end P. The torsional reactions, that is TP and TQ, at the ends of this is respectively, they are the TP and TQ are asked. Okay, so what you do, see at this point, that is at the point, this value is going inwards. So just converting this to like this value is 150, and take the reactions like this. This is TP and this is TQ. So the first equation we will have that TP plus TQ is equal to 150. This is first equation. Okay. Then second, that what I have told you for finding the reactions at the ends, you can find that is TP is equal to 150. See, plus minus, this will be a plus sign because both are in opposite. So into 150. Then the distance of this torque, applied torque from the other end, that is 200. Okay. And then divided by the overall distance, that is 300. Okay. So just this 2 goes off. This is 50. The 50 into 2 is 100. So this is 100 Newton meter. The TP is 100 Newton meter. So the TQ will be equal to 50 Newton meter. So the correct option is 100 and 50, not 50 and 100, okay, but 150 because TP is 100 and TQ is 50. So the correct option is option C and not option A because it is also 50 and 100, but the 50 and 100 are 100 is for P and Q is for Q, it is 50 Newton meters. Okay, the one more method can be there, then you can find the theta total and that you can substitute as equal to 0. Okay, so that will be TL by GJ, the summation of TL by GJ for both the cases, that will be equal to 0. From here also this can be used as the second equation, this can be used as the first equation, and then also you can find the value of TP and TQ. But this is the more simple method when the shaft is there and the G into J is same for both the shafts, because this is the same shaft, so the G and J will be same. Okay, so that's all for this one. The previous year solved papers on torsion and bending. If you have any comments, any doubts, you can write to us on the Gradeup app and on the website. Your feedbacks are always welcome. Till then, you have to solve as many questions as possible from the test series, the quizzes, the mocks that we are providing you. Okay. So in the next class, we will be taking some new topics on the subject of strength of materials, and then we will be continuing forward in this course. So see you in the next class. Till then, thank you. Bye.